Assalamualaikum to Dr. Muhammad Asri and Dr. Siti Nohaida. My name is Harith bin Adnan and I will present my project Sarjana Muda 2, which is the development of a liquid fertilizer spray with angle control nozzle that are supervised by Dr. Shamsul Anwar bin Samsudin. For the research background, the agriculture of durian in Malaysia grew exponentially as the demand from the local and international consumer is high. The application of drone has become the new alternative in agriculture as it can provide a lot of benefit to the farmer. The agriculture drone is an unmanned aerial vehicle used to help optimize agriculture operation, increase crop production and monitor crop growth. Next, I will continue with the problem statement, objective, and scope of the project. The first problem statement of this project is the criteria of the available drone in the market need to be analyzed and compared to choose the most suitable product that can be used in durian orchard. Next, the drone need to have suitable component and parts to be used for spraying fertilizer and pesticide, crop mapping and surveying, and crop monitoring. And lastly, since the use of agriculture drone in durian orchard is a new method, more study need to be done to determine the best way to utilize the drone to increase the efficiency of using this new approach. As for the objective, the first one is to study the architecture design of the agriculture drone that are available in market. Secondly, to customize the drone with suitable component and parts. And the last objective is to investigate the spraying mechanism and pattern suitable for durian planting. This project has three scopes. The first one is the specification of drone in the market are compared to determine the compatibility to complete given task. The second one is the the research about working mechanism of the agriculture drone are compiled to provide guideline of the work process. The component and parts of the drone are designed using the computer-aided design software. Next, I will proceed with the literature review. There are four types of application of drone in durian agriculture. The first one is crop spraying. Next is spot spraying. The third application is crop mapping and surveying. And the last application is irrigation monitoring and management. Now I will continue with the basic principle of the drone. The drone is made up of chassis, propeller, motor, flight controller, and battery. There are three parameters of the agriculture drone that are being considered. The first one is the type of nozzle. The nozzle is selected based on the spraying application to increase the efficiency of the spray and prevent droplet drift. Next is the camera and sensor. The drone need to have the camera and sensor for visual evaluation and data collection of the crop. And lastly, the drone need to have enough lift force for the drone to fly when carrying heavy payload. The drone is estimated to be able to carry around 20 kg of total weight. Okay, now I will proceed with the comparison of available agriculture drone in the market. The parameter of each drone is tabulated in the table to ease the process of evaluation and comparison. As you can see, each of the drone have their own unique characteristic and function. Now, I will continue with the methodology section. This is the flow chart of my project. It starts with the literature review and the comparison drone in the market. Then, product specification, conceptual design, screening and scoring were made to obtain the design of the drone. If the design satisfies the customer requirement, then it can proceed the detailed design in CAD drawing. After that, the prototype of the drone is ready to be tested using analysis and simulation software. Next, I will proceed with the customer requirement. The first one is functionality. The product need to be able to apply fertilizer, irrigation, pesticide and herbicide to the crop. Second is portable design. The product need to be easy to be carried around anywhere. Next is easy to use. The product should need to be user friendly and have simple instruction manual that can be easily understand. As for the durability, the product should not break easily by random hazard. And lastly, reusable. The product need to have long lifetime and can be easily recharged for continuous use. The spare part of the drone should be easily obtained. Okay, next I will go through the engineering characteristic. For the type of material, the material used for the drone will be mostly carbon fiber that are durable, lightweight and flexible. Next is portable design. The drone can be disassembled to smaller components and can be reassembled back easily. Uh, Next is the attachment. The drone can have multiple attachments such as different type of spray nozzle, camera and sensor. For the reusable, the part of the drone can be easily exchanged if failure of the component occur. And lastly, for the operating system, the drone can be operated by using radio control transmitter as commanded by the user. Okay, next, this slide show the house of quality that compare the data that defining the relationship between the customer requirement and the engineering characteristic. Okay, next, this slide show the morphological chart that provide several options for the type of drone, spray tank, type of visual, input power, and lastly, type of nozzle. Now I will continue with the concept design based on the morphological chart before. The table showed each of the selected option based on the criteria from the chart to obtain the concept design A, B, and C. Next is the screening method. To choose the best concept design, we can compare the strength and weakness of each concept using this method. Concept design B received the highest score compared to the other concept. Next, the weighted decision matrix is also used to evaluate the concept design by ranking them with weighting factor and scoring the degree of which design meet the criteria in this method. Concept B also received the highest score. Now, I will proceed with the result and discussion. The picture shows the finalized design of the drone according to the concept design produced based on the morphological chart. The design is then evaluated proportional to the design that received the high ranking of the screening method and the weight decision matrix table. Next is the CAD drawing of all the component and part based on the finalized design of the drone. For the design testing, since the laboratory experiment and fabrication process cannot be done due to the current pandemic of COVID-19 disease, the CAD drawing of the drone will be tested using simulation software. The first test is the static structural analysis on the frame of the drone. The second test is the computational fluid domain CFD of the airflow at the propeller. The third test is the CFD of the airflow at the nozzle. For the first test, which is the structural analysis, the strength of the frame was tested using ANSYS simulation software to determine the stress and deformation of the frame when the force exerted on the body of the drone. This simulation will determine the condition of the body of the drone during real-life operation. In the workbench, the static structure was chosen among the analysis system. The material for the frame of the drone, which is carbon fiber, need to be selected from the engineering data source to the software. Then the CAD file of the frame need to be converted into step file to make sure it can be exported into the ANSYS software geometry. The carbon fiber material were assigned to the top and bottom frame and also the leg of the frame of the drone. Then the geometry undergoes meshing process where the frame of the drone was meshed using body sizing mesh with size element of 10 mm. Then the force of 200 Newton is added in Y direction where this is the downward force due to weight of the drone during takeoff. The fixed support is then inserted at the bottom of the leg of the frame to make sure there is no displacement at the leg in Y, X and Z direction. The result of the simulation is obtained after running the calculation in the simulation software. From the simulation, we can obtain the total deformation and stress experienced by the body of the drone. The maximum total deformation of the drone is at the top of the frame. The frame experiences approximately 0.078 mm of deformation. The maximum stress is experienced by leg of the drone. It experiences 1.506 megapascal of stress. Next, I will continue with the CFD flow simulation of the propeller. This flow simulation was done to obtain the thrust force generated by the propeller. The solution from the simulation can be used to determine whether the propeller and the speed of the motor was enough to generate thrust force to lift the heavy agriculture drone. In the workbench, the fluid flow fluent was chosen from the analysis system, and the CAD drawing of the propeller was exported into the geometry of the axis in the form of step file. In the design modular, two enclosures were added to the propeller drawing. The first enclosure was the rotating domain in the shape of cylindrical. The second enclosure is the static domain in the shape of rectangular. Then, the boolean were added to subtract the body of the propeller and the enclosure. In the meshing part, the face sizing mesh was inserted to the 7th face of the rotation domain and the face of the propeller. The size of the mesh was set to 40 mm. Then the mesh is generated to obtain the result as shown as the figure in the slide. The velocity of the inlet was inserted with a value of 10 meter per second. This velocity speed is the average speed of the drone using during the operation in the farm. The rotation domain was set to mesh motion in the y direction, and the speed of the rotation is set to be 524 rad per second, which is equal to 5000 rpm. Once the calculation is done, the thrust value can be obtained by selecting the propeller in the force report. The maximum thrust generated by the propeller in this simulation is approximately 54.08 Newton. Then, from the calculation, we can say that the propeller generates enough force to lift the drone during full payload, as the total thrust generated is higher than the drag force. Next, I will continue with the CFD flow simulation of the nozzle. The flow simulation was done to observe the velocity and the pattern of the discharge particle. The outlet velocity of the nozzle can be observed. The fluid flow fluent was chosen from the analysis system for this simulation. In the design modular, the design of the nozzle was made according to the sketch parameter and the revolve feature as shown in the figure in the slide. Then, the cylindrical shape was created around the nozzle to act as the static domain. The Boolean feature was used to subtract the nozzle from the domain. In the mesh generation, the edge mesh is inserted at the bottom and the top of the edge of the cylindrical domain. The number of division of the edge mesh is set to 24, and then the mesh is generated as shown as the slide. The material of the particle, which is water, is selected from the Fluent database material to be assigned as the particle for this simulation. In the boundary condition, the inlet velocity is set to be 10 meter per second. From the simulation, we can observe that the maximum velocity of the discharged water particle is at the outlet of the nozzle. The maximum velocity of the flow is 2582 meter per second. The simulation also shows the pattern of the discharge particle along the domain. Okay, next I will proceed with the final chapter of the report, which is conclusion and recommendation. In conclusion, all of the objectives of this project have been achieved. The comparison between different types of agriculture drone has been made in the form of table and figure to compare their unique own parameter. This report also provides the suitable way of applying the fertilizer, which is directly to the leaf of the tree, the foliar fertilization technique. The simulation of the nozzle was also done to obtain the velocity of the discharge particle and the particle formation along the domain during applying fertilizer. Lastly, this report also concludes the design of the part and component of the drone using computer-aided design software. These components are important as the agriculture drone need to have this part so that it can fully be operated to be used by the farmer managing their farm. Next, for the recommendation, first one is to fabricate a working and small prototype of the drone for testing scheme. After the prototype is fabricated using the 3D printing process, it can undergo some experiment to produce experimental value that can be compared with the simulation value obtained from the NC software. Next, other simulations such as the airflow simulation on the full body of the drone can also be done to determine the wind trajectory during the takeoff operation. Lastly, if the prototype produces great result, this project can proceed into making real product with all the required function and then be tested in the real farm to monitor its performance. I think that's all for me. Thank you.